Hello solar energy fans and welcome to the PVSYST tutorials. This is the interface of the PVSYST. Actually, PVSYST software is a great software because you can design with the PVSYST the grid connected systems and the standalone, which is off-grid, and the pumping and DC grid. And we will focus on these tutorials on the on-grid system. So this is the project design. Go to the grid connected. This is the project name. For example, let it be full solar. Okay, and this is the site and meter. Now here you can choose your project's location, and this is the countries. Okay, and this is the cities. And if your location is not here, you can add the location from database and geographical site. By the way, this is the data including in the PVSYST. So go to the geographical site and, for example, Asia and Abu Dhabi. Abu Dhabi already existed, but we will see how we can insert or add a location. Open it, change the name to the full solar and import the data of radians. Click OK and save the data. Okay, now back to the project design, grid connected and the site and meter. Go to Asia and we will see the full solar location. Okay, choose it and save the project. Okay, now the next step is the design of the system. Go to the orientation and enter your orientations of the PV arrays. Okay, for example 27, and the azimuth is 0. Note that here the 0 represents the south, and in the SketchUp the south was 180 degrees. Also, you can change the orientation to several orientation if you need more tilt angle. For example, if you have more one PV arrays and each PV arrays has different orientations. Okay, back to the fixed. Okay, this is the orientation. Go to the system. Now this is the numbers of kind of subarrays. We need sometimes to insert more subarrays. For example, if we have an inclined surface like this, and this surface is to the west and this surface is to the east, and we need to put solar PV panels here and here. So as we discussed before, we can't put the difference panels condition together, so we will put the east side panels together and the west side panels together. So we insert one more subarray and complete the design. Note that these two subarrays is one system. Okay, now this is size system, for example 5 kilowatt, and this is PV module. This is the manufacturer of PV module, and this is the PV panel, and you can see the data of the panel here, and this is the inverter selection. This is the manufacturer also, and this is the inverter. For this example, 5 kilowatt peak system, choose 300 for example, and ABB inverter, choose 5 kilowatt. Now this is the data of inverter, which is the operating voltage MPP, the minimum MPP voltage and the maximum MPP voltage, and this is the absolute maximum voltage. This is the kilowatt AC over the inverter, which is the output side. This is the number of MPPT. Okay, now this is the number of series of modules, which is a PV array, and the number of string, which is the PV arrays connected parallel together. So change the number of panels and strings to get the power that you need. This is the power here. For example, 2 string, because we have 2 MPPT, and increase the panels, more one, Now the array nominal power STC under the STC conditions is 5.4 kilowatt peak. This is so good. This is the num ratio, which is the DC AC ratio as we discussed before. And this is the number of modules and the area approximation. This is the frequency of the inverter. Here we are in Jordan and we use 15 Hertz frequency. Okay, now we enter the data of panels and inverter and the system size. If you increase the number of string, we will see message here. This block is the messages block. As you enter the data, the message will be so. When there is no message, your design is good. If we increase the number of modules, we will see a message here. And if we increase the number of string, we will see also another message, which is the array has 3 strings to be distributed into 2 MPPT inputs. So when this block is empty, your design is good. Back to our case, which is 5.4. If you increase this number of modules, we will see the num ratio increasing. So back to 9. Okay, now this is the system. We work on net metering, user needs. It's a household consumer. Okay, now we can make the simulation for this system. Simulation. We will get reports and the tables. This is the reports of the system. As you see, the tilt angle, azimuth angle, and the modules used, horizon, free horizon, no shading, PV array characteristic, the PV modules data and the system size, and the inverter data and size. And this is the produced energy per year. And this is the production. You can see the energy of the arrays during the year and the energy to the grid. And this diagram is the loss diagram. The system output is 2 megawatt. And after the losses, which is the PV loss due to the irradiance and the temperature and the inverter losses, the power output will reduce to 9.28 megawatt. So this is the loss diagram. Let's include the power output of the system total and after the losses. So this is the system report that we can make by PVSYST. And in the next video, we will make another design of PVSYST. See you in the next video and thank you.